Good day! For today's video, we're going to have solving rational inequality. Our learning objectives are the following: solve rational inequalities and solve problems involving rational inequalities. In the previous discussion, we defined a rational inequality as an inequality that contains rational expressions. And here are the examples. It uses the inequality symbol less than, greater than, less than or equal to, greater than or equal to, or the not equal to. But unlike in rational equation, where the solution set could be 1, 2, or none, rational inequalities has infinite solutions. It is for this reason that we need to understand first how to write or represent the solution set of rational inequalities. Here are the ways on how to describe a set. First is by verbal description. Example, set A is the set of counting numbers less than 5. Set B is the set of letters in the word Philippines. Set C is the set of positive multiples of 5. Now, this verbal description can be written using a rooster method. It is a method of describing a set by listing each element. For set A, we can write the elements 1, 2, 3, and 4 for the set of counting numbers less than 5. For set B, we have here P, H, I, L, N, E, and S for the letters in the word Philippines. We only list the element once. We discussed that one before. And for set C, we have 5, 10, 15, 20 for the positive multiples of 5, and we use here the ellipsis, which is the 3 dots here, which indicates that there are positive or there are infinite elements that follows after 20, which are multiples of 5. Another way to describe a set is using set builder notation. It is a method that lists the rule that determines whether an object is an element of the set rather than the actual elements. For example, we read this one as the set. Set A is the set of all x's such that x is a counting number less than 5. Set B is the set of all x's such that is a letter in the word Philippines. Set C is the set of all x's such that x is a positive multiples of 5. Or we can have this example. This symbol E is for the word is an element of. The symbol Z is for the word the set of integers. And this vertical line is for the word such that. So we can read this one as all x that are elements of the set of integers such that x is between 0 and 4 exclusive. We use the word exclusive here since 0 and 4 is not included or not part of the solution set. But if we will have the equal sign here, so we will read it as the set of all or all x that are elements of the set of integer such that x is between 0 and 4 inclusive. When we say inclusive, it is included or it is part of the solution set. The last method of describing a set is using the interval notation. So we have the open interval. We use the open and close parentheses AB indicates that x is greater than A but less than B. That is, x assumes all values in the interval except the endpoint A and B, meaning A and B exclusive or they are not part of the solution set. And then we have the closed interval. We'll be using the open and close bracket that indicates that x is greater than or equal to A but less than or equal to B, meaning that from A and B and all those values between them. And the last one is the half open interval. We have here open parenthesis A, B, close bracket, or open bracket A, B, close parenthesis, which indicates that one of the endpoint is part of the values of x and all the values between a and b. Here, it's either a or b is part of the solution set. Now, this one is the interval notation, and this one is the inequality notation. So, we will be using this one as we go on with the topic. Among those four ways of describing a set, we will be using the interval notation for the solution set of rational inequalities. So, we have here the summary for the inequality notation interval, and we will be including the graph. Now, if it is exclusive or not, or the endpoints are not part of the solution set, we have here the greater than and less than for the inequality notation. For the interval notation, you're going to use the open and close parentheses, and for the graphs, you will be using the open circle. Now, if it is part of the solution set, if the endpoints are part of the solution set, or the points are part of the solution set, you will be using, for the inequality notation, you have here the greater than or equal to and the less than or equal to. For the interval, you're going to use the open and close bracket. And for the graph, you have shaded or closed circle if they are part of the solution set. Okay, so let's have some examples. Given x less than 3 for the inequality symbol. So if we're going to list the elements for this one, the elements are 2, 1, 0, -1, and so on and so forth. So those are the elements for numbers less than 3. So if we're going to plot it, since 3 is not included, we're going to have an open circle at 3, and the arrows will be pointing to the left. So these are the solution set for x less than 3. Now to write it in interval notation, the arrowhead here to the left will indicate an infinity. Since it is pointing to the left, you will have a negative infinity, and then also 3 open and close parentheses, because infinity indicates lots of solution set or infinite number of solution sets. So we will write it open and close negative infinity up to positive 3 exclusive. Okay, did you get it? Let's have another example. Let's have x is greater than or -5. Again, if we're going to list the elements of the numbers greater than or equal to 5, you will have 5, 6, 7, 8, and so on and so forth. So, graphing it, you will have a closed circle at 5, and the arrow will be pointing to the right. So, those are the elements. Okay. So, to write it in interval notation, so a closed circle indicates you're going to use the open bracket, and then this is an arrowhead pointing to the right, you're going to use positive infinity. So you will have open bracket 5, infinity, open. I hope you can follow the discussion. Let's have another example. You have here x greater than or equal to -6 but less than 2. So if we're again listing the elements, we will have -6, -5, -4, and so on and so forth up to +1 because 2 is not included. So to graph it, you will have here a closed circle at -6 and an open circle at 2. So the elements can be found between them, so you just connect the two dots or the two circles. So those are the parts or the graph of the solution set. And then for the interval notation, again, closed circle is bracket, open circle is parentheses, and then you copy the point. So you will have open bracket, -6, and then 2 close parentheses. So this is how you do it. As simple as that. Next example, you have x is greater than 0 but less than 4. So the elements here are 1, 2, and 3 only. So graphing it, again, we will have, so since this is exclusive, 0 and 4 is not part, so you will have an open circle at 0 and 4, and then you just connect them. And then for the interval notation, you will have open parentheses and close parentheses, and then copy the points, so you will have this one. That is how you write it in interval notation. Okay, And then let's have the last example. This time you have x is greater than 1 or x is less than or equal to negative 5. So you have here two solution sets. Let us graph first x is greater than 1. So the numbers greater than 1 are 2, 3, and 4 and so on and so forth. So that means your arrow will be pointing to the right, but you will have an open circle at 1. Okay. And for x less than or equal to negative 5, so those numbers less than negative 5 are negative 6, negative 7, and so on and so forth. So you will have an arrow pointing to the left and a closed circle at negative 5. So you will notice that the solution sets are separated. Okay. Now to write it in interval notation, so we will first write this one in interval notation. So again, negative arrowhead or an arrowhead to the left indicates a negative infinity, and then you will have negative 5 close bracket. Okay, and then for this one you will have an open parenthesis for 1 and an arrowhead pointing to the right is positive infinity, and then we will just use the symbol union. So you will write this one as the union of these two solution sets, or yung pinagsamang sagot dito at saka dun. So that is how you write it. Okay, I hope it is clear. And I hope you did follow the discussion. We will be using this now to solve for rational inequalities. In solving rational inequalities, here are the steps that we're going to follow. First, rewrite the inequality in general form. Or we're going to rewrite the inequality as a single rational expression written on one side and then 0 on the other side of the inequality symbol. 2, you're going to set the numerator and denominator equal to 0 to solve for x, but you have to factor the numerator and denominator first if it is possible. And then we're going to locate the x values for which the expression is undefined. Or we call this one as the critical values. And then 3, break the number line into intervals by plotting the critical values on it. And then 4, test the number from each interval. If the inequality is true, then it is part of the solution. But if it is false, then it is not part of the solution. And finally, you have to determine and write the solution set. Okay, let's have now the example. Solve the rational inequalities x plus 2 over x minus 3 is less than or equal to 0. So the first step is to write it in standard form. The inequality will be on the left side and on the other side is 0. So since this one is already in single form or general form, so we will now proceed to step number 2. So set the denominator, the numerator, and denominator equal to 0, factor if possible. So since this one are already prime, so we just simply equate the numerator to 0 and the denominator to 0. So we will have x plus 2 is equal to 0 and x minus 3 is equal to 0. Solving for x, we will have x is equal to negative 2 and x is equal to 3. And then step 3, break the number line into intervals by plotting the critical value. So we'll have it the graph. So for negative 2, since x plus 2 is the numerator, so this one will be a closed circle. So we will have a closed circle at negative 2. And then since this is denominator, we cannot have 3 for the value of x since this will be undefined. So meaning 3 is not part of the solution. So it will make the rational inequalities undefined. So we will have an open circle for 3. So this will give us 3 partitions. So we have here A, B, and C. So the whole number line is divided now into 3 parts. So these are the critical values. Now for step 4, test a number from each interval. If the inequality is true, then it is part of the solution. If the inequality is false, then it is not part of the solution. So let's have it in table. So we will have x plus 2 the numerator, x minus 3 the denominator, and then the whole rational inequalities. Okay, so for the partition A, you will select any points here. So for example, we use negative 3. as part of partition A. So we substitute negative 3 to this. So you will have negative 3 plus 2 that will give you negative 1. And then here you will have negative 3 minus 3 that will give you negative 6. And then for the whole expression, you will have negative 1 divided by negative 6 that will give you positive 1, 6. And then to test, 1 over 6 is 1 over 6 greater, less than or equal to 0. So this one is false. Okay, now let's use now another number for partition B. So for example, we select 0. Any number here, you can use negative 1, 0, 1, 2, but I'll be choosing 0. So you will have here 0 plus 2, again substitute here, you will have 2, and then 0 minus 3, you will have negative 3, and then when we divide this one, 2 divided by negative 3 is still negative 2 over 3, and then we check now if it is part of solution set. So negative 2 over 3 is less than or equal to 0. So this one is true. Okay. And then for the last partition, you can use 4, 5, or 6. So let me choose 4. So you substitute again. 4 plus 2 is 6. 4 minus 3 is 1. 6 divided by 1 is 6. So 6 is greater than or equal to 0 is also false. So since you have now the solution here, all we have to do is to determine and find the solution set. So since this one is true, okay, partition B is true. So looking at the graph, so you will be using this portion. So again, this is closed circle. You will have bracket and then negative 2. And then you will have open circle 3. So you can write it in inequality notation or interval notation. So you will have this one. So x is greater than or equal to negative 2 but less than 3. Or open bracket negative 2, 3, close parenthesis. So this will be your answer. You can write it in interval notation or inequality notation or both. So much better you write it both. Okay, so I hope it is clear. These are the steps in finding the solution set of rational inequalities. Let's have example number 2. Solve for 2 over x divided by x plus 5 greater than or equal to 1. So here, the right side is not yet equated to 0. So we have to simplify this one. So we transpose 1 to the left side. Or you subtract 1 on both sides of the inequality. So writing it in general form or single form, we will have this one. But since this is not yet single form, we have to subtract negative 1 from 2x over x plus 5. So we need to find the LCD for this one. So the LCD will be x plus 5 divided by x plus 5, that will give you 1 times 2x. So here you have here 2x. And then x plus 5, that will be multiplied by negative 1. So we will have this one, negative 1 times the quantity x plus 5. Simplifying this, you will have 2x minus 5 over x plus 5 greater than or equal to 0. And then simplifying further, we will have 2x minus x is x minus 5 over x plus 5 greater than or equal to 0. So this time, this is now the general form or the single form of this expression or of this inequality. Okay, so you can use this one or this one. So step 2, we're going to set the numerator and denominator equal to 0. So we'll be using this one. So the numerator will be x minus 5 and the denominator x plus 5 equate to 0. So we will have now the critical values x is equal to 5 and x is equal to negative 5. Okay, let us continue the solution. So we have here step 3. Again, we're going to plot the critical values. So for x is equal to 5, since it is in the numerator, you have closed circle, and then for negative 5, which is in the denominator, you have an open circle. This again will give us 3 partitions, A, B, and C. So for step 4, we're going to test values for each interval or for each partition. So for partition A, let's have negative 6. So I will be using x minus 5 and x plus 5. So this one. So you have here the numerator x minus 5, x plus 5, and then the whole expression. So negative 6 minus 5, that will give you negative 11. Negative 6 plus 5 is negative 1. And then negative 11 divided by negative 1, that will give you positive 11. So to test whether it is part or not, true or false, we will have 11 is greater than or equal to 0. So this will be part of the solution, or true. Now for partition B, again, let me choose 0. So 0 minus 5 is negative 5. 0 plus 5 is positive 5. So divide this one, you will have negative 1. So negative 1 is greater than or equal to 0. That is false. Then for letter C, you can use 5 since it is included, or you can use 6. But to be safe, you just use the numbers after the broken line. So you can use 6. So 6 minus 5 is 1. 6 plus 5 is 11. So 1 divided by 11 is 1 over 11. So 1 over 11 is greater than or equal to 0. So this is 2. Now, you can also use this expression, the original one, to test for values. Let's see if we're going to get the same result. So, ito ang gagamitin natin. So, same partition. So, let's try negative 6. So, for the numerator, you have 2 times x. So, you will have negative 6 times 2 is negative 12. And then negative 6 plus 1 is negative 1. So, divide this, you will have positive 12. So, 12 is greater than or equal to 1. So, again, this is true. And then, for letter B, again, let me choose 0. So, 2 times 0 is 0. 0 plus 5 is 5. 0 divided by 5 is 0. 0 is greater than or equal to 1. This is false. And then, for letter C, again, we'll use 6. So, 2 times x or 2 times 6 is 12. 6 plus 5 is 11. 12 divided by 11 is 12 over 11, and this is also equal to 1 and 1 over 11, which is greater than or equal to 1, so you will have true. So again, we have the same result. So the partition A and partition C are the solution set. So looking at the graph, you will have here partition A, so you will have your negative infinity up to negative 5. Okay, so negative infinity up to negative 5, open and close parenthesis. And the union of partition C, so you will have here close circle, you have bracket 5, and then to the positive infinity, open. So this will be your solution set. Okay, I hope this is clear. Okay, let's have another example. You have solve x squared minus x minus 30 divided by x minus 3 is greater than or equal to 0. So, first step, single form. So, we already have 0 on the right side. So, you can proceed to step number 2. Set the numerator and denominator equal to 0. Since the numerator is still quadratic, so we can get the factors of this one. So, you will have x minus 6 and x plus 5. And then, set all of them, numerator and denominator, to 0. So, for the numerators, you will have x minus 6 is equal to 0 and x plus 5 is equal to 0. So you will have x is equal to 6 and x is equal to negative 5. For the denominator, you will have x minus 3 is equal to 0. So you will have x is equal to 3. So these are the critical values. Now for step 3, so we will plot it and then determine the partition. So we will have this one. So for the numerator, 6 and negative 5, we will have a closed circle. And then for 3, which is the denominator, we cannot have a positive 3. It will make the whole inequalities undefined, so that will be an open circle. And then we will have this time 4 partition. So we have A, B, C, and D. So let us test now. Okay. You can use x minus 6, x plus 5 here. And then this one. So for partition A, let us use again negative 6. So negative 6, I will be using this one. Negative 6 minus 6 is negative 12. And then you have negative 6 plus 1 is negative 1. So negative 12 times negative 1, that will be positive 12. And then negative 6 minus 3, that will give you negative 9. Divide this one and reduce, you will have negative 4 over 3. So negative 4 over 3 is greater than or equal to 0. So this one is false. And then for partition B, again, let me use 0. So that will give you only negative 30. And then 0 minus 3 is negative 3. Negative 30 divided by negative 3 is positive 10. So 10 is greater than or equal to 0. That will give you true. That is true. So this one is part of solution set. Partition C. So let me use 4. So we will have 4. Let me use this one again. So 4 minus 6 is negative 2. And then you will have 4 plus 5 is 9. So negative 2 times 9 is negative 18. And then 4 minus 3 is 1. Divide this one, that will give you negative 18. So negative 18 is greater than or equal to 0. Again, this is false. And then for the last partition, you can use 7 or 6 since it is included. But let me have 7. So again, let me use this one para mas madali. So you will have 7 minus 6 is 1 and 7 plus 5 is 12. So 1 times 12 is 12. And then 7 minus 3 is 4. 12 divided by 4 is 3. So 3 is greater than or equal to 0. So this is true. So therefore, your solution is partition B and partition D. So let us determine the solution. So looking at partition B, so you will have here open bracket and then open bracket for negative 5, and then you will have here close parenthesis for 3. And the union of partition D, so you will have 6 bracket, this is included, pointing to the right, so that you will have here the positive infinity. So this will be your solution set. The union of negative 5, 3, including negative 5, and including 6 to the right of 6. So this will be your solution set. I hope it is clear. Okay, let's have the last example. Solve 3 over x minus 2 is less than 1 over 3. Again, we have to write it in a single form. So since the right side is not yet equal to 0, so subtracting negative 1, subtracting 1/3 on both sides, or transpose 1/3, so we'll have this one. So, and then since this one is not yet in single form, we have to find the LCD. So the LCD for this one is 3 and x minus 2. So 3 times x minus 2 divided by x minus 2, that will give you 3 times 3. So you will have 9. And then for this one, we're going to cancel 3. Remaining is x minus 2 times negative 1. So you will have the negative of quantity x minus 2. And then we simplify this. Negative times x minus 2, that will give you 9 minus x plus 2 over the denominator, which is less than to 0. And then you have 9 plus 2, that will give you 11 minus x over, we multiply this one, you will have 3x minus 6. So this is now the single form for this inequality. For step 2, we're going to set the numerator and denominator to 0. So you will have here x is equal to 11, and here transpose negative 6, it will give you 6, dividing both sides by 3. So x is equal to 2. So 11 and 2 are the critical values, but we cannot have x is equal to 2. So this is not part of the solution. Okay, let's have step number 3. So we have to plot now the critical values. So for the numerator 11, you have an closed circle. So let's just put the 11 here. So that is closed, and then you have here for 2, you will have an open circle. So we'll have 3 partitions. Okay. And then for letter C, let us test. So we will be using this one, x 11 minus x over 3x minus 6 is less than 0. So for partition A, let's have 0. So 0, 11 minus 0 is 11. This will be 3 times 0 is 0 minus 6, so we'll have negative 6. And then we divide this one, that will give us negative 11 over 6, or that is 1 and 5 over 16 is less than 0, so this will be true. And then for partition B, you choose any number here. So that will give, let me choose 3. So 11 minus 3 is 8. You will have 3 times 3 here is 9 minus 6 is 3. So 8 divided by 3 is 8 over 3, or that will give you 2 and 2/3. So 2 and 2/3 is greater than or equal to, is less than 0. So this is false. And then for partition C, we can use 11 since this is part, or you can use 12. So 11 minus 12 is negative 1. This is 3 times 12 is 36 minus 6, so you will have 30. Divide them, you will have negative 1 over 30 is less than 0, so this will be true. Okay, so test it here. And then to find, so the solution set are partition A and C. So write it in inequality again. Partition A, this one, so you will have the negative infinity up to 2 open and close parentheses, and the union of partition C, so you will have here 11 is included, so we'll have bracket 11 to the positive infinity. So this will be your solution set for 3 over x minus 2 is less than 1 over 3. You can also choose use this one to test the values, but you will still get the same answer. Okay, I hope everything is clear and you did follow the discussion. Okay, this ends our discussion. Please see the next video for the topic graphing rational functions. Thank you.